All right, welcome to Foundations of Math and Pre-Cal 10. This is outcome 10.07, lesson 3 on parallel and perpendicular lines. So just a quick reminder that parallel lines are two lines that are equidistant at every point. What that means is that they never touch. And the symbol for parallel lines, if you don't remember it, is this little two line segments side by side. Perpendicular lines, those are two lines that meet at a 90-degree angle. And the symbol for that is like the upside down T. One other thing we're going to talk about is the reciprocal. So remember that that is interchanging the numerator and denominator of fractions. So for example, if I have the fraction 2/3, the reciprocal is 3/2. We flip it upside down. Okay, so we're going to be looking at parallel and perpendicular lines and how their slopes are related to one another in this lesson. So let's just hop right into it. So I want to graph the lines on the same Cartesian plane. So on the graph paper here, I'm going to graph line A, B, and C. So line A goes through -1 and 4. Oops, -1 and 4. And the point 3 and 6. 1, 2, 3, 4, 5, 6. Okay, and then we can get our ruler out and draw that line through those points. I know you can't see my ruler on there, but I've got a ruler. Remember, we take it right to the edge, lines on either end. That is point or line A. I'm going to do them in different colors. Line B is through the point 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And the point 2, 3, 2, and 3. And we're going to connect and draw that line. So that goes through there. That is line B. And line C is through the point 3 and 5. 1, 2, 3, 2, 3, 4, 5. And 4, 3. 1, 2, 3, 4. 1, 2, 3. And then we're going to draw the line through those points right to the edges, arrows on the end, and that is C. Okay, so there are my lines drawn. Now we're going to talk about them. So list the lines that are parallel. So parallel means lines never touch. So we know that A is parallel to B. They definitely look like they're parallel there. And the perpendicular lines, so those are the ones that meet at right angles, right? So there and there. So I could say that A is perpendicular to C and B is perpendicular to C. So I've got two sets of perpendicular lines. Now we want to calculate the slope of each line. Okay, so if I go to line A, and because I have a graph, I mean, we could use our slope formula if you like, or I'm just going to count it off on my graph paper. So I'm going to go up 2 over 1, 2, 3, 4. So my slope here would be 2 over 4, and if I reduce that, that's 1/2 for line A. Line B, from my points that I plotted there, are up 2 over 1, 2, 3, 4. So my slope there is also 2 over 4, or 1 over 2. And on C, it is down 2 over 1. So my slope is -2 over 1. So my question is, what do we notice about the slopes of the parallel lines? Well, they're both 1/2, so they are the same, right? What about the perpendicular lines? Well, if you look at them, one of them is 1/2, one of them is -2 over 1. So they are opposite signs, right? And they are reciprocals. 1/2 and 2 over 1 are reciprocals. So what I know is that in general, parallel lines have equal slopes, and perpendicular lines have what we call negative reciprocals. Slopes, okay? So they are opposite signs. If one's negative, the other's positive, and they are reciprocal, so 2/3 to 3/2, for example. Okay, so let's just determine if each pair of lines passing through these given points is parallel, perpendicular, or neither. So if they're parallel, their slopes will be the same. If they're perpendicular, they'll be negative reciprocals. And if they are anything else, they will be neither. Okay, so we're going to calculate A and B, right? So because I don't have a graph, I am going to use my slope formula. Again, if you wanted to graph them and count it off, you could totally do that too. So this is x1, y1, x2, y2. And when I go to do this one, it'll be x1, y1, x2, y2. Okay, so I'm looking first at this point A right there. So my slope is 2 take away 4 over 1 take away 5. So that gives me -2 over -4, which when I reduce that becomes positive 1/2. Then I'm going to calculate the slope of line 2, or B. Okay, so my slope formula is y2 minus y1. I'm a creature of habit. I write my formula out every single time. It's just the way my brain works. y2 is 1 take away -2 over 6 take away 0. So 1 plus 2 is 3 over 6, which is 1/2. So because these slopes are the same, these are parallel lines. Okay, so we know that those two are parallel. Let's take a look at C and D. So there's C and, oh, C and B, I guess it is. So C, again, slope is y2 minus y1 over x2 minus x1, x1, y1, x2, y2. So it's going to be -2 take away 4 over 3 take away -1, -6 over 4. So when I reduce that, it's -3 over 2. You always want to reduce your fractions. And this b here, so slope is y2 minus y1 over x2 minus x1, x1, y1, x2, y2. So my slope is 2 take away -2 over 4 take away -2, which gives me 2 plus 2 is 4, 4 plus 2 is 6, which gives me 2/3. Okay, so one's negative, one's positive. They're reciprocals, so that means that these two are perpendicular. Okay, so I had one parallel, one perpendicular. If you got slopes like -3/2 and 5/8 or something like that, then those are neither parallel or perpendicular. Okay, our last example here is find the x so that the line with the coordinates x3 and 1, 7 is parallel to the line with the coordinates 2, -4 and 5, -2. So what's really happening here is I have a line. I'm just going to draw a quick sketch 2, -4 and 5, -2. So I have a line here that I know the coordinates of. And then I have another line that is at 1 and 7 and something and 3. So there's some point somewhere along the line, right? So that I want these two to be parallel. And when the y value is 3, basically I want to figure out what that x value is. That's what it is asking me to do. So what I need to do first is find the slope of that blue line. Okay, so I want to find the slope of this guy here. So my slope of that is y2 minus y1 over x2 minus x1. Let's number them here, x1, y1, x2, y2. Oops. Okay, so then I know that my slope is -2 take away -4. Again, be careful with your signs. Over 5 take away 2. So -2 plus 4 is 2 over 3. Okay, so now I know that the slope of my red line is 2/3. Okay, so we're now going to take a look at our red line, which is going to be here. And what I know is that because these lines are parallel, the slope must be 2/3. And if I call this x1, y1, x2, y2, oops, y2, I can plug in everything that I know. So y2 is 7, take away 3 over 1, take away x. There's my unknown. So I'm going to simplify anything I can. So 2/3 is equal to 4 over 1 minus x. and then I cross multiply. So I end up with 2 times 1 minus x equals 12. Distribute through the bracket. 2 minus 2x equals 12. I've run myself out of room here. I need to subtract 2 from both sides. So I'm just going to go over here. So I end up with negative 2x equals 12 minus 2 is 10 over negative 2. So I get x is equal to negative 5. Now if I look at my picture, that seems like it might be reasonable. I mean, this was just a sketch, but it is on the negative side of here. So this value right here is negative 5. Alrighty, so what I want you to do is to practice. So there are some points. So these 2 points are like, I want to know if these are parallel, perpendicular, or neither. Okay, for here, you're just responding to, so if a line is parallel to a line with a slope of 3, what would the slope be? Is it the same? Is it negative reciprocals? What would it be? And then in number 3, I've got a line on the grid here. I want you to draw me any line that's parallel. So you can draw me anywhere on the graph a line that's parallel and a line that's perpendicular, and then find me the slope of each. Okay, so you go ahead and practice those now.